In the previous video, we learned about the binary number system, and we learned that computers use binary to represent numbers because it's easy for computers to keep track of a lot of ones and zeros. But for humans, keeping track of all those ones and zeros is very cumbersome. And for this reason, humans prefer two other number systems when working with computers, and one of these is the octal number system. The octal system is based on the number 8, and therefore we need 8 numerals in octal, 0 through 7, and each octal digit will represent a power of 8. So for example, in this number 3725, the 5 represents units, the 2 represents eighths, the 7 represents 8 times 8 or 64s, and the 3 represents 8 times 8 times 8 or 512ths. So that means we have 3 times 512 plus 7 times 64 plus 2 times 8 plus 5 units. And so converting this from octal to decimal gives us 2005 in base 10. Now if we want to go back the other way and convert a decimal number to octal, then we need to apply a procedure which is similar to what we did in converting decimal to binary. Namely, we need to divide repeatedly, but this time we're going to divide by 8. And again, we write the remainders right to left, and the last quotient that we get will be the most significant digit. Okay, so for example, we need to convert 859 in base 10 to octal. So we divide by 8, we get 107 with remainder 3. So that means 3 is the least significant digit in octal. Then we repeat. 107 divided by 8 is 13, remainder 3 again. Okay, so 13, we divide that by 8, and we get 1 with remainder 5. So our octal number is 1533. Now, on the other hand, if we need to convert a binary number to octal, this is much easier, and the reason is, of course, that 8 is 2 raised to the 3rd power, and so all that we need to do is just group the bits by 3 from the right, and then write down what each group of 3 bits would be in octal. Okay, so for example, we need to convert this long string of ones and zeros to octal. Okay, so we start by grouping the bits from the right in groups of 3, and then we simply write down what each group is. So here we have a 2 and a 4, that's 6. There's a 4, 2, there's a 3, there's a 5, 1, 2, and a 1. So that's all there is to it. Okay, and if we need to convert from octal to binary, it's just as easy, just by converting each octal digit to the corresponding 3 bits.